many zones, there is possibility that you require at least 2 keys per zone. It's a ZSK key, zone signing key, and KS key. It means key signing key. So you have at least 2 keys. Next, you have to change the keys from time to time. So to change the keys, you require to generate another pair of keys. So you have 4 keys in the zone, because you have to publish a ZSK key and KSK key. If you would like to migrate to the new algorithm, you need to put another keys, to sign the zone with new algorithm. So you have keys for an old algorithm and for the new algorithm. So you have 8 keys. I see this is, and you also should be able to keep the old keys in the HSM, at least for some time.
Okay.
So
I don't mean to take too much time, but just one more thing. You said the M of N authorization. Would you mind if you just give me a little bit explanation of this part, the M of N authorization?
It means that you have a minimum number of people who are required to, for example, authorize to the device to do some procedure. But you choose them from there is a wide group of people who are authorized to do this procedure. For example, you can have 3 of 7, I guess, this is the standard model. So there is 7 people who can do some procedure, but you require only 3 of them.
Okay, thank you.
This is redundancy.
Okay, no other questions, so thank you very much. Thank you very much, Christoph.
Thank you very much.
Now, Thomas Gustafsson from Part3 will tell us about EID for the cloud, which is certainly a very hot topic. Hopefully, he will keep with his 10-minute slot.
So, hi, my name is Thomas Gustafsson and I'm with Part3 and we work with PKI. So, today I'm going to tell you a little bit about cloud computing, which is kind of a buzzword for the last couple of years. But there's actually a lot of investment going on in cloud computing, and that's why it's interesting, and also both for private companies and the government can draw a lot of benefits from that. And to couple this with electronic IDs, of course, I will discuss the challenges to come with the cloud computing and how that relates to EIDs. So basically, if you go to a cloud conference, something like the first day is spent on actually figuring out what cloud computing is. So, but basically, here I will only put it in one sentence. It's basically the economics of scale, which is applied to IT. So that, of course, brings promises like commoditization, standardization, and lower cost. There are lots of research and reports being conducted on cloud computing. So these are just a few points which come from the World Economic Forum, which has done a 2-year research in this area, both about the possibilities, of course, and barriers. So the real possibilities, I mean, why is everyone so eager about cloud computing? Basically, it's to enable new services and products, to create new businesses and jobs. People really say, wow, now we're going to have 300,000 new jobs in Europe, or 1.5 million new jobs in Europe. Of course, reduced cost is always a key driver for anything. For governments, they can improve effectiveness a lot. And one thing that is often pointed is that you can lower cost of failure, so you can try a lot of new things without investing a lot of money, which makes it very expensive if it fails. You can try things. And even people even say that it contributes to GDP growth. There are reports who claim that 50% of GDP growth in Europe is driven by IT. So by making IT more effective, you can even get higher GDP growth. And I think a lot of people here in this conference are here because you want to provide better services for your citizens. And a lot of countries are actually building national clouds. I mean, there are different types of clouds out there. There are public clouds like Amazon, etc., where you can rent IT resources. But governments are also building government clouds. Great Britain is building a cloud, Singapore has one, India has one, etc. So there is a lot of investment and drive behind this. But to come into the EID part then, this is just also another borrowed slide from Oasis Cloud Symposium I was on 2 weeks ago. It just describes how the EU's spot carbon emission market was stopped because of security problems, security breaches. And that is run as a cloud service for different parties in the EU. So this just shows that people really want and require stronger authentication when they deploy cloud services. EU, here they even talk about mandating to use two-factor authentication, which is a typical usage for if you have a national ID card with PKI based on it. So that was the possibilities, the great future of cloud computing. So what are the barriers? Well, actually, the biggest barriers are all security related, which makes it so interesting from our point of view, of course, as PKI implementers. All different organizations who look into cloud computing talk about basically the same barriers. We have a World Economic Forum, ENISA, Cloud Security Alliance, Oasis. They all talk about problems with privacy, jurisdiction, data protection, trustworthiness and compliance. I mean, those are kind of the business terms. If I try to take it down to more technical terms, it means that you need better authentication, electronic IDs. You need audit. I mean, you don't really have any security if you can't show that you have security, or if you can't look into that you actually have security. And the same concerns for security are for both users and governments and the private sector. Everyone talks about the same barriers to actually getting the real benefits that you look for with cloud computing. I mean, you can of course use cloud computing even without authentication, or without strong authentication, without good audit capabilities, etc. But to really reap the benefits, you need to overcome these barriers. So to talk about PKI in the cloud, or EID in the cloud, well, EID usually has some sort of PKI component involved, but PKI is PKI. It has been around forever. It's basically a ubiquitous security infrastructure. You secure the communication, you authenticate resources, you have electronic IDs, PKI based most of the time. You use digital signatures and encryption to protect your data. And this has been around forever, and that's not going to change just because we call something cloud or not. But what is changing, or what is happening, is that organizations actually want to use their electronic IDs for authentication. And this is another borrowed slide, basically. What companies want a solution that offers consumer a simple yet or safe, just simple solution that enables them to reach all their customers, because that's also one thing about the cloud. Everyone talks, when they talk about the cloud, they mention that you scale things up to a much larger scale than you're used to. And it has to be cost effective, and that's actually one of the benefits of scaling things, because then you can get lower cost per unit. And of course it has to be future proof. So what we want to do is to look for ways to leverage existing ID infrastructures. And EIDs have traditionally had this kind of chicken and egg problem, where you don't issue electronic IDs because there are no usages, or you don't start EID-enabled services because there are no users, and the users are not using their EIDs because there are no services. So that's a kind of classical problem related to EIDs. So, but we can easily, I think, scale up existing infrastructures because there are everything out there. So this is also a borrowed slide from BGC at the conference we had. So there's nothing new invented here. Everything worth inventing has already been invented. So we only have to put things together in a good standardized way. When you talk about if you're a service provider who wants to provide services, and you want to, of course, use all out different authentication methods available to authenticate people in your service, then you have the problem that it's going to be both complex and pretty expensive, because you have many different EID providers. In Sweden, for instance, we don't have one national EID yet, but we have several different providers of electronic IDs for use for strong authentication. And then on top of that, as a service provider, you will probably also want to have different levels of assurance for different things, different services that you provide. So you want to look for simpler identification methods and different authentication methods for different purposes. So, and in this case, an EID gateway can be a good idea. So as a service provider, you actually have, as a cloud service provider, you actually use another cloud service which is the EID gateway, who hides the complexity of talking to all of these different EID providers. Probably a little bit similar, I mean, to how Stork is trying to integrate different EIDs across Europe to be able to use them. It's the same problem. So you have different EID providers within a country, and you also have different EID providers all across Europe, and you want to be able to reach out to all of the customers, actually. That's the problem. And that's what an EID gateway can help you to achieve. And as a service provider, you want to use all cloud-friendly standard protocols like SAML and XACML, which makes your solution actually standardized. So you don't have to develop specific modules or specific protocols to reach to all these different types of IDs, electronic IDs. But you have one mean of getting to all your users. So this is my last slide, I think. So the basic message here is that there are lots of states deploying national IDs, and we can use those IDs to enable strong authentication for both private and government applications, which we can make very broadly available in the cloud or not, of course. One thing that is very important for wide deployment of identity solutions is to use open standards. Because it rarely happens, or almost never, I would say, that a closed proprietary solution, at least, I mean, on the interface protocol level, it will never reach a very broad deployment. And, well, Pedro will now talk a lot more about CC Core that can help with audit compliance, and I mean, lots of software like that. Thank you.
Any question?
I think have an idea about the DigiNotar incident?
Sorry?
DigiNotar incident. Do you have any idea about the incident?
Yes. What about?
My question is, what can we do in terms of PKI to prevent such incident?
Well, that's a tricky question. Of course, the DigiNotar incident has kind of spurred up a lot of doubts about the current trust infrastructure in PKI, or that is currently used at least by how do you say, the broadly deployed software, user software, and the way that they manage trust. So it has stirred up a lot of discussions about different ways to handle trust, because that's all an issue of trust actually, that you're kind of forced upon to trust on a lot of different certificate authorities which may not be so trustworthy. So there are, I think, a lot of different suggestions how to improve this infrastructure today. And well, one thing that's for sure is that the ones that are left, since DigiNotar doesn't exist anymore, they have definitely gotten an incentive to look over their rules, etc. But we will see. There's probably going to be some change in the way that trusts are managed in the web browsers, for instance. How it will look like, I don't know it.
Okay. Second question. Root CA, self-signed CA, must be online or offline? Because, in my opinion, online CA, that's the case of DigiNotar, it's a big risk. We can all time attack the...
Well, in my view, offline CAs are only suitable if you issue like a few, one certificate a month or something like that, and that's not scalable. Anything that should be scalable and cost-effective, of course, has to be online. Because if you want to reach out to millions and millions of citizens and you use PKI in this kind of automated fashion, you have to be online. Otherwise, it doesn't scale. So, I mean, parts of PKI of the infrastructure can be offline, of course, but that's only like root CAs. But other parts, which are more often in operation, they can only be online. Otherwise, it doesn't work.
But I think we can use an offline CA used only to sign sub-CA, which sign citizen, and at the same time to use another CA, which can be online, but with the same key pair.
Sorry, I didn't get the last word.
Excuse me?
I didn't hear your last sentence.
I think we can say an offline CA can also work. It's not necessary that must be online. It can be offline. I think that's the best to prevent such incidents, because when the root CA is offline, we are sure that anybody can attack the...
Yeah, well, actually, root CA can be offline, yes, but still you can attack the sub-CA, and because everyone gets the certificate from the sub-CA. If you attack the sub-CA, you can issue certificates that are trusted. And then if that CA is compromised, you still have a compromise of the whole sub-CA, which you have to revoke then.
Okay.
Thank you.
Thank you very much. I think you may continue maybe the discussion offline. Thank you very much, Thomas. And now we'll continue with Pedro Borges from Portugal, from the company Beyond IT, who will tell us how to use common criteria certification.
Good afternoon. I'm Pedro Borges, as Mr. Galera already said, and I'm here to present the project that I had the pleasure of managing for the last 2 years, give or take, which is CSA Core, and I'll explain a little bit better what that is. First, so that we have some common vocabulary, I won't get into too much information about this because common criteria is a world of its own, and if you are interested on it, we can discuss it afterwards, certain details of the project. But basically, when I speak about common criteria, what I'm really speaking is about common criteria for information technology security evaluation. So I'm addressing an evaluation scheme that's designed to make sure that certain products, either software or hardware, are secure, are not only specified and designed in a secure way, but are also implemented and tested and evaluated according to certain rules that are followed thoroughly and very rigorously by all parties involved. It is also